Good morning. Thanks again for attending today. Today we're going to concentrate on one specific type of application when it comes to safety interlocking and safety system, and that is the use of devices like this when they're stored energy. Now, many of you may be familiar with interlocks as they are generally on a guard door, whether it's machine mounted or perimeter mounted. The idea is that when you open the guard door, the machine stops. All right, that's fine. However, machine powers down, there may be a rundown time, stored energy, like a saw blade. That's simple enough. It doesn't stop immediately. It may take a few seconds to come to a stop. For those unfamiliar with stop time calculations, the way that OSHA describes this, let me give you an example. You have a saw blade that takes 2 seconds to come to a stop. The saw blade is 18 inches away from the door. So when you open the door, 1001, 1002, saw blade stops. Is that good enough? Seems kind of fast, doesn't it? 2 seconds? Yeah, it should be. OSHA says you can reach 63 inches per second. Yeah, that's fast. That's very fast. But then you can do the calculation simply and say, hey, you know what? 2 seconds, that's, oh my goodness, that's 10 feet. We don't have 10-foot arms, but at the end of the day, that's how it's calculated. So this is a hazard analysis, and at the end of the day, needs to be responded to in some way. In this instance, we want to lock the door. We want to prevent people from gaining access. And from those that may be familiar with interlocks, this is a solenoid locking safety switch, which utilizes a key. The key ultimately locks the door until power is provided to the solenoid to drop it out, which means unlock the door, gaining entry. Sometimes this is provided by a safety rundown timer, but probably the more professional way to handle this is put a couple sensors on the blade to make sure that it comes to a stop. That feeds the PLC, telling the PLC, unlock the door. Then, of course, then you can gain access. So traditionally, solenoid locks are usually in this type of application when stored energy is a requirement. Now, years ago, this was an appropriate product along with safety relays or safety PLCs that may be in the panel to backcheck circuit failure. Well, times have changed. Those familiar with safety interlocks understand that these keys, while they might be not necessarily on your plant floor, they could be ordered in quantity from anywhere. The idea is a spare key can then be used to bypass. Now, that's a bad thing, and obviously you probably have rules against that. But if you take a look at the OSHA statistics in terms of fatalities during the year, you'd find that there's a lot of folks that are operating this machine under full power with the door open. Yeah, that's a bad thing. At the end of the day, this type of interlock system isn't foolproof as it is available with spare keys, and at the end of the day, that causes problems. The other problem, of course, is the fact that you have systems like this that have problems with circuit failure, be it shorts, jumpers, loose wires. So folks, this is a dumb switch. That's it. You need to make it a smart device, and that might include then a safety relay, a safety PLC. And yeah, now how do we prevent this from happening? Well, the industry has moved along and we're provided a system which utilizes non-contact. Now, non-contact back in the day was considered a coated magnet. Again, we're back to that same thing, that a magnet system like that can be purchased separately and be used to bypass. Well, this is an RFID system. An RFID system has a 32-bit code, which is unique to the tag. The reader is also a safety system unto itself. In a teach mode, it learns this tag's number. So at the end of the day, there is no spare key, perhaps, that would be used to gain access and keep the door open, allow that machine to operate. The other benefit with RFID over coated magnets use a variety of magnets underneath the shell. The orientation is north, south, north, and reverse polarity on the other side. As long as the door doesn't vibrate or shift, that works okay, but a 2mm offset and it trips. And folks, let me tell you about safety. When it trips a lot, that production goes down, then bypass occurs. So it's a bad system if it ultimately doesn't allow the machine to operate under normal conditions. An RFID system is one field, if you will, and the offset can be as much as 11mm off of center, any direction. So that provides a lot of vibration overcomes vibration, misalignment of the guard door to a certain point. So a locking switch to hold the door closed, another RFID safety system on the door to provide limited bypass capability and so on. That would be a system. Well, what we've done over the years is we've taken that dumb locking switch, the diagnostics and the RFID system, and placed it into one component. That component, in one case, is a, let me just get this off my screen. Is a locking system that overcomes a lot of the sins of traditional locking switches. To begin with, instead of a forked key, we have a bullet-shaped plunger, or actuator, if you will, and it's spring-loaded in all conditions. So it more or less can overcome some of the sins of a guard. The front of the switch has a wide funnel. That's where the actuator goes in and locks in. Also note that that funnel goes completely through. That means any material that gets clogged onto the actuator gets pushed out through the other side. Again, that doesn't happen with a traditional locking switch. It just builds up inside and causes problems, of course, with the key entry. So at the end of the actuator, we have an RFID tag. That's that black square that you see there. That's my 32-bit tag number. You'll also see the target just below the funnel. That's the reader. So when closing the door, this system's been set up to record that tag number prior to startup. And then from that point on, it wants to see the one that it was programmed to see when the door is closed. We've added extra devices on here, push buttons, and generally you'll see this on a robotic cell. It's a request to enter, reset, e-stop. That's a separate box. Well, in this instance, we put it all into the same system. So you have essentially a multifunctional gate box system. It has a optional key override. I want to call that an override. What this is when the door is open, one can take an administrative key, place it in the unlocked condition, take that key into the cell with them, and now no one can start the door, even if it's, or start the machine, even when the door is closed, until that's put back into the on state. So a mechanical key prevents anything from happening. The reverse side of this is a called egress. In any robotic cell where someone can get trapped inside, they need to have a means of getting out. The regulations state that this cannot be an electrical e-stop or something like that where the circuits can be screwed up or something. It has to be mechanical. So we can see the door is locked. If I was the inside, I would hit this and allow me then to open up the door. The head is rotatable. So you have this set up for hinged, and then removing 4 screws from the top, you can reverse that to the other side for a side-mounted actuation, so again, for sliding doors. So this system unto itself is a Category 4 safety system. For those familiar with safety categories, that's the maximum level. It's also performance level E, which again, based on the performance of this device, will last 30 years plus, regardless of the number of operations you'll see. And it's a SIL 3 safety system, safety integrity level. All those folks that are out there that are familiar with safety may have heard one or the other term, Category 4, performance levels, SIL levels. This is the maximum product that's available on the market that meets all those requirements. There's not a SIL 4, there's not a performance level F, and there's not a Category 5. Ultimately, this is the maximum that you can get, not just because it's locking, but because any fault condition will be detected. Now, we put this system in conjunction with a handle system. I'm going to bring that over. Let's see. All right. There's my switch. You notice that the pilot devices are backlit. Yeah, they're LED. Also note that this is red in color. Now, red is what? Stop. So at the end of the day, If this was a robotic cell, we'd know that the machine will stop just by the sheer color of the handle. We would open the door. Let's say we're performing some maintenance, then we have a lockout assembly that can come down and put padlocks around to prevent anyone from starting the machine until the padlocks are removed. It's a ball catch. So in the end, we pull it up, it stays up, we close the door, and we're off and running. Okay, the next step would be to what? Start the machine. So we'll hit the start button and it goes green. Think of this like a stack light on the door. Awesome, right? Because stack lights aren't necessarily in a place where you can see them. They're maybe 10 cells down or on a group of cells, and you don't know which cell does that particular stack light represent. Or it could be an HMI, again, 10 feet away, that you'd have to go up and say, what's going on with that machine? This tells the operator or whoever's interested what that machine is doing at that particular time behind that door. Doesn't take rocket science to figure out the machine is running out, right? It's green. Now, the next step would be, of course, is to enter. And an enter condition ultimately means someone's making a request. That's usually by push button, a request to enter push button. The problem we have with locking switches and operators are impatient. So what happens is they'll push the button and keep pulling on the door until the solenoid drops out. Now, a couple things happen. While you're pulling on the door, you're backloading the solenoid. The potential for that solenoid not to drop out is there. A good example would be you're walking up to a passenger side of a car door and you're pulling up on the door handle and someone else is hitting the unlock button and it doesn't unlock. It's because you're backloading the solenoid. What we want to do is we want to inform the operator that this machine has not yet stopped. And what we're going to do is we're going to take this and we're going to request to enter. And I'm going to start flashing a yellow light, which means the machine is coming to stop. And once it goes red, now it's time to open the door. So we request to enter, it's flashing yellow. And then when it goes to red, now it's time to open up the door. We open the door, close the door, and we want to hit the start button again, and we're good to go. The next condition would be considered an emergency stop. Now, an emergency stop, if it's set up correctly, requires a reset on the machine. That's right, it was an emergency. That means a reset of not only the e-stop button perhaps, but also of the machine to get back to the run state. So I have this e-stop on the front of my switch and it's in series with this particular one. It's showing off the lighted LED if you want to use that method as well. So we hit the e-stop, turning blue, flashing, telling you that it's coming to a stop. Now, blue is the generic color for reset. So we mechanically reset this. I hit start, it's not happening. Why? Because we're in a reset mode. Reset mode means I have to reset the equipment, then I can hit start and go. Now, this particular system here is on the exterior is all plastic, but inside it's 10-gauge steel. The face of this can be just strictly aluminum. That means no light, no push button. Or it could be the lighted version without the push button. Or it could be just a simple push button that's lighted in any color without the light. Or as this system shows you, it's available with both color of the lens as well as the push button. This particular system has a 7-color option, meaning you can purchase it with 7 colors and you can use all 7 or you can use 3. It's up to you. But keep in mind that each color is informing whomever what's happening. Whether the machine needs parts, it should need up in service soon, or under service, whatever the case might be. That tells you a lot. In fact, I oftentimes refer to it as a visual information system. Someone asks me, what the heck is that? And I go, it's a stack light. It's a stack light that fits right on the handle and ultimately then can give anybody all kinds of information as long as you've assigned the color and trained the operator what those colors mean. Now I have another system where we've removed all of these buttons to show you that maybe you don't need all those buttons to operate the machine. Let's take a look. All right. This locking safety system, failed to mention it earlier, is available in plastic. So the locking force of the all steel version is 9,750 newtons. You're not going to open that door. This is 2,100 newtons, more than sufficient. And at the end of the day, has again the hole that goes through the middle. And yeah, it can be mounted on any plane. So for sliding doors, for hinge doors, this works out just fine. And again, the actuator is the same type where it's pivoting, and my RFID tag is at the base. So let's take a look at what this system is doing. This is pretty cool. I love this idea. I went to Amazon not so long ago in Seattle, pre-COVID, and I showed her the unit that, this was the robotic division, that had all the pilot devices. She goes, you know, we got good people, but they get confused with buttons. You know, do you have anything that's simpler? I said, yeah, I've got a system that just has no buttons. All right, so walking up to this robotic cell, one would see the red color and they only see one button. So if he only sees one button and the supervisor says, go over and start that robot, he said, well, I guess I just push this button. What's it go? It goes green. Why? Because that's the next sequence. If the machine is off, the next step would be to turn it on. Well, the next step when it's on is to what? Turn it off. So you hit the same button. Now it's flashing yellow, telling you that the machine is in their stop mode and it goes red. Now perhaps you open up the door and you want to put the lockout on. The lockout is the same idea, slides up over the front, padlocks in are applied here, and then we're off and running. Well, take our padlock off, close the door. The next step would be to start the machine again. Goes green. Well, what happens if we hit the e-stop somewhere? That's been, maybe the e-stop station was applied on the equipment. Well, it goes blue. Blue obviously means it's running down and now needs a reset. We reset, we hit the start, that's resetting the machine again. Now it's back to red and go again. How about that? We can actually run this machine off of one button. Why? Nothing magical here. The colors represent exactly what the machine is doing. The sequence is always the same. You don't go from start or stop to reset. You go from start to e-stop or start to stop. It doesn't change. There's no adjustments here when you're running a machine. It's either on or off or needs a reset. So in the end, this product is also available with push buttons and add-on. If you want push buttons, they're there. If you don't need push buttons, then obviously you can purchase it without push buttons. And the same can be said for the metal version. The metal version is available without pilot devices, with either 2 buttons or 1 button. Could be the e-stop or start. So there's many options that are available because many people have different ways of operating the equipment. On this particular setup here, we're also showing our hinge safety system. That's a 315 stainless for high wash down areas and of course high corrosion areas. It works just like a safety switch, meaning it has a safety system so that when you open up the door, I'll show you this pilot light. We're going to request to enter. Yeah. Okay, good. See this light? As soon as I open the door, it goes out. That's because it's tied to this safety hinge. The safety hinge is load bearing rated. So I think it's over 150 pounds per hinge. And yeah, there are dummy hinges so that you could have a pair of hinges, one doing the diagnostic safety and the other one just holding up the rest of the door. This particular product is available with or without the integrated diagnostics. In other words, 4 sets of contacts out, which would be back checked by a safety relay. And then if you don't need all that expense or stainless, we also have the hinge switch available as a 4-contact unit, which could be tied back to anybody's safety PLC or safety controller. Speaking of which, of course, Pizzato does offer safety controllers, safety relays, e-stop systems, enclosures, rope pull switches. and a whole variety of limit switches depending on your position requirement needs. Okay, that was essentially it. We were going to focus on one particular product and one type of application, which was stored energy. I was wondering if there are any questions that people might have in regards to these products today. Keep in mind that your distributor and has the local rep has these demos available locally. And yeah, they can obviously come into your facility and you can see the equipment either in static form or operational on these guard doors. We look forward to working with you in the future. Just let us know how. Again, any questions?
I'm taking a look here. Again, folks, you can type in your questions in the navigation, or you can raise your hand if you would like to participate. I have a question. Did you say you can come on site and help figure out a particular situation, how to adapt to those solutions, or what's the first steps to going about and getting started?
Great question, Joel. There are so many types of guards out there. And the problem that we have with machine builders, ultimately they're looking for the lowest cost solution. And the lowest cost solution may work for a while. And then when it starts acting up, there's a lot of downtime. And all of a sudden then safety looks like the bad guy here. In reality, it's just the wrong product for the application. So our local representatives and our distributors have sample cases with a variety of our safety products. And in the end, by looking at the guard door, understanding the issues that you might be having, can recommend a alternative. I'm oftentimes asked, well, you know, I'm using your competitor safety switch. And it's a crappy switch. What do you got? I said, I got crappy switches. Sounds funny, right? Look, in the wrong application, they're going to drive you crazy. Now, if someone's safety switch like this is acting up on you, chances are mine's going to do the same. So what do? You go to a different product based on how the door operates. You find a solution that meets the guard's needs so that when the door opens, it stops. But when the door is closed, the machine runs. Now, we're not going to do risk assessment for you because that's ultimately something that, as a company that provides components, isn't in a position of providing you in terms of this is what you got to do on the machine. We can give you guidance. Risk assessment today is a third-party methodology, is approved by ANSI. That would be ANSI B11.0. I would suggest those that are interested in upgrading their equipment to the latest requirements, they're not options, is to buy that particular risk assessment methodology. It also mirrors ISO 12100, which is the international standard, and follow those requirements to properly select the right product suited for those applications. Really, in risk assessment, there's two different types. One type of injury is what's referred to as, I call it broken finger stuff. Essentially, what the extent of the injury maximum is nothing more than something that can come back to normal. A broken finger obviously can come back to normal. Pinch can come back to normal. Disfigurement and loss of life are equal. Why? Because it's permanent. If we lose a finger, we're not frogs. They don't grow back. If we're dead, we're not Frankenstein. We don't come back either. So if you want to look at it this way, you look at the safety requirements as being, if the safety fails, how bad can I get hurt on this? And then take it from there. It's not a simple procedure just to say a switch is necessary. You have to look at, for again, the example was the locked application because of stored energy. You know, during the safety category decision, locked isn't part of the equation. However, hazard analysis is, and that's where someone has to step in and say, hey, that machine doesn't come to a stop as soon as I open the door. And someone has to do the calculations to establish whether or not a locking system is required.
Makes sense.
Yeah, it does. And at the end of the day, you have to be looking at state-of-the-art safety systems because these types of products are no longer valid unless you can bury the switch in such a place that with a spare key, you couldn't engage the port. Now that's almost impossible because the keys are usually mounted to the door and the switch is where you can find it. The requirement today, if you want to use these, are considered to be low-coded devices. They have to be buried into the machine where someone with a spare key cannot engage it. So at the end of the day, guys, RFID safety is the best and the most preferred method because all of these issues that are associated with these products go away. And there's a variety of these types available in terms of size, functionality. Some have built-in permanent magnets just to hold the door closed. Others have a way of putting them in series to operate the machine where you don't have to use all that safety I/O. I encourage you to contact the distributor and have the rep stop in and take a look at what those problems are, and then we'll come up with solutions and take it from there. I conduct machine safety seminars all over the country for OSHA inspection classes at various universities, as well as in industrials and OEMs. It's an hour and 40 minutes long. It's generic. We use our products as examples, but nothing specific to Pizzato itself. We start out very basic, where all this information came from originally. There are animations to show how the proper interlocking should be and improper, and then doing risk assessment to show you how that methodology works. We also do cover some of the legal aspects relating to citations, fines, and of course, product liability. Again, I would suggest go to Pizzato USA, go to the support tab, and you'll see safety seminars, and it will give you a rundown of the topics that are covered. This is a no-charge seminar. The idea is we want to introduce you to Pizzato, but at the same time, give you a sense of what is going on right now in terms of safety and the necessities, of course, that your company has to meet, whether it be an end user or an OEM. At that point, get a hold of the distributor. They have my travel agenda, and at that point, we can organize maybe a lunch and learn.
Yeah, we're going to follow up with the users as well, so we can include some information on how to get a hold of whoever they need to.
Okay, great. Well, thanks again for the time today, and I look forward to seeing you sometime in the future.
Thank you for the great presentation, and thanks for attending, everybody.